All right. So, in the last class, I was talking about different failure mechanisms to make you aware of different ways in which parts can fail. Now, before we move on to the failure models and after that the design of each of the machine elements, let us take a look at different materials which are used for making engineering components. Knowing about the material and their physical behavior is very important uh, for figuring out as to what sort of analysis you need to consider.
Illumo,
Please,
illumo.
please keep your mic on mute. Somebody. Okay. Now, today and maybe possibly in the next class, we are going to look at different materials which are used for making components. Broadly speaking, the materials that we use for making engineering components are classified into three groups: polymers, metals, and ceramics. Okay. Now, amongst the polymers, there are different classifications. Polymers which we use can be put into different groups. One classification is based on the kind of bonding you have between polymeric molecules. The polymers that you deal with, you may either be dealing with molecules which are covalently bonded or which are held together using van der Waals forces of attraction. Whenever you have, who is this who is constantly unmuting? So, whenever you have covalent bonding, you refer to that particular polymeric material or polymeric material as a thermoset. So, the most popular example of thermoset is vulcanized rubber. Okay, you must have learnt about vulcanization of rubber earlier. So basically, you use you mix sulfur in rubber, you heat it up, and then it leads to interlinking of these polymeric molecules. Now, uh, vulcanized rubber is one example. Now, epoxy is something that many of you must have used. The common brand that we work with is Aeroldite. So, in most of the thermosetting materials that we use, you have two components, a resin and a hardener. You take these two components, you mix them together, and you have an exothermic reaction leading to this bond formation and formation of a set material or formation of a solid material. Now, epoxy is a hard thermoset. Now, bakelite is another of the thermosetting materials. Bakelite is used for making utensils handles, the ones which you use on gas stoves. And bakelite is also used for making these electrical switches. Now, a, a elastomer, a thermosetting material which is which can be stretched easily. An example of that is silicone. So, vulcanized rubber, bakelite, aeroldite or epoxy, silicone, these are all examples of thermosets. One of the very important properties of thermosets is that they are thermally and chemically stable. Particularly, they have very good thermal stability. What does it mean, thermal stability? What it means is its properties will not degrade, they will not degrade with increasing temperature. So that is the reason that, so if you take tires for example, now there will be a lot of friction and heat generated at the interface between the tire and the road. If you take your hand, press it against the table, and you do your hand back and forth, you can feel the shear stress, you can feel the frictional heat on your hand. Now imagine the kind of condition a tire would experience. There is a lot of load. So if you take a car tire, it is experiencing somewhere around 300 to 500 kgs of load between at the interface with the road. Now at this particular loading, if you have some amount of sliding or complete sliding, you can imagine the kind of heat which will be generated. Now, despite the heat and shear stress, you do not want the material to soften or wear out. Okay, so you need materials in such kind of applications to not degrade with elevated temperatures. Now, similarly, uh, silicone, okay, so silicone molds are used in cooking many a times. So I don't know how many of you have interest in cooking, but if you're making chocolate or so for several applications you would pour very hot stuff into these silicone molds. In fact, these days you also get these silicone brushes for applying oil on pans. Okay, when you're making dosa, omelette, or whatever on pans, you can use these silicone brushes. So basically, and for this, nothing is required to be specified about the kitchen utensil handles. The handle can get hot very quickly, but you do not want your this handle plastic material to soften with heat. So wherever you want thermal stability and also to an extent chemical stability, you go with thermosetting materials. Thermoplast, but there is a big disadvantage of this good thermal stability. Can you please explain, let's say, the major disadvantage of using the thermoset? So what is the problem with tires, for example?
So they tend
They
to
cannot be
get
recycled.
brittle over time and shrink.
They cannot be recycled. Okay, so setting something into a permanent shape, the problem is that you cannot reuse the material after its purpose is over. So let us say after a tire is worn out, it has exceeded its life, you would want to reuse that material for doing something else, but then you cannot recycle it, you cannot melt it and put it into another shape. Okay, so recycling is a major problem with thermosetting materials. So for this reason, there has been a great push to work with thermoplastic materials. So thermoplastics, if you break down the word, thermo means temperature, plastic means ability to change the shape. So for these class of materials, for thermoplastics, you can heat the materials and soften them, and then you can push them into any shape that you desire. So majority of the plastic parts that you see around you these days, they are all thermoplastics. So if you take Lego blocks, chairs, water bottles, these are all made out of thermoplastics. So one classification of polymers. So whenever you think of using a polymer in your application, you need to ask yourself whether you want to go with a thermoset or you want to go with a thermoplastic. And the answer to that depends on whether you have a requirement that the material should not soften upon heating. It should have good properties even at elevated temperature. So if you want that property, then you have no other option but to go with a thermoset. Now, another classification of polymers is based on their mechanical behavior. You may either be dealing with polymers which are very stretchy, okay, which you can deform to a good amount of a good extent, and such sort of polymers are referred to as elastomers. Unlike metals, elastomers can be stretched to very large strengths. Many, so you must, of course, all of you have used balloons, right? So if you take a balloon, What is the kind of stretch, or what is the kind of strain, engineering strain, which a balloon which rubber used in balloons would experience? Take a number. What would be the percentage engineering strain which rubber used in balloons would experience?
10,000.
5 to 10.
Yeah, they would easily be experiencing around 5 to 10,000. Sorry, not 10, not to 5,000. They would be experiencing about 500 to 1,000% stretch, or maybe more. Okay, which is enormous as compared to metals. What is the typical strain which a metal can be subjected to at room temperature? If you take steel, aluminum, what is the typical strain that you can subject it to before it fails? Steel, aluminum, how much strain can you subject it to? Can you subject it to 2%, 20%, 200%?
0.02.
0.02 is what? 2% strain. 2% is very small. You would not be able to see much of a shape change really if it is 2%.
No, sir, 0.02%.
0.02 is extremely small. You will see nothing really.
Sir, 7 to 8%.
You can
6.57.
subject most of the metals to about 20 to 50% strain. Okay, that is the typical strain that you can subject them to. So polymers can be subjected to about 1 to 2 orders more stretch or strain as compared to metals. So among the elastomers, the most popular ones are vulcanized rubber, SBS, silicone, nitrile butyl rubber, and polyethylene. Okay, now polyethylene. Now, if you okay, so you can see from the pictures, you can see what is the application that they can be used for. Okay, now in addition to some utility items, silicone and nitrile butyl rubber play some very important role in engineering applications. They are used for making gaskets, okay, or they are used for providing sealing between the inside and the outside. What property of the material would make them very highly suitable for making gaskets? Name some applications where you have encountered gaskets.
Pressure cooker.
Pressure cooker, okay. What else?
Water pumps.
Basically many applications, yeah. Water pump. In fact, if you open up a cell phone, a mobile phone, you would see that anytime you have a lid and you're closing it up on something, there would be a rubber gasket. Okay, what is the purpose of these gaskets?
Sealing.
Sealing. Okay, why do they help in sealing?
So because they can deform and take the empty gaps.
Very good. Because they are so soft that when you apply pressure on them, they spread out and occupy whatever space is there between the two members. Okay. So even if you take a automobile, let's say a car, you would see that between the car door and the frame, you have this rubber gasket. Okay, and many a time the rubber which you use is nitrile or butyl rubber. So nitrile or butyl rubber is used for room temperature applications. If you have elevated temperatures, then you would go with silicone. Okay, so another classification is based on the stretchability of the polymer. So if you can stretch them a lot, they are referred to as elastomers, and these are some of the popular elastomers. My favorite amongst all is silicone. Okay, and then the nitrile butyl rubber. Now,
So,
yeah,
I have a confusion. Like you said that silicone, they can be in the category of thermoset, and again, thermosets are not that elastic.
No,
Uh,
no, no,
and
I didn't say that. I said amongst thermosets you have some varieties which are hard, like bakelite and epoxy, and
okay,
some which are stretchy, like vulcanized rubber and silicone. Okay,
okay, okay,
so
yeah,
thermoset doesn't mean it is hard. It just means that if you heat it, it is not going to soften. It has much higher thermal stability, and its bonding is different between the polymeric molecules.
okay. Thank you, sir.
So another classification based on the hardness of the material is well, you have these hard and stiff plastics. Okay, amongst the hard and stiff plastics, the most commonly used one is PMMA, polymethyl methacrylate, also called acrylic. Okay, now acrylic is a hard and transparent plastic which can come in many colors, and you have seen these plastic tubes, chairs, and the rear the the tail lights, okay, of automobiles. They have a covering made of acrylic. So wherever you need a high scratch resistance and you need a transparent material, you can go with acrylic. Now, polycarbonate, on the other hand, it is also transparent, but it has another very important property, that it has very high impact resistance. Okay, so you must have heard this word bulletproof glass. So many times when the prime minister, chief minister, when these people give speeches, they are standing behind a glass, means what looks like a glass, but that's not really glass, that is polycarbonate. Glass is brittle. Glass can never stop a bullet or anything really. So polycarbonate is very tough, and whenever you want toughness, what is toughness? How do you understand toughness?
by indentation testing.
So toughness means resistance to fracture. Okay, you cannot crack it easily. So for example, if you take a nail and you take a hammer and hit the nail against a acrylic plate, acrylic will crack, but polycarbonate will dent. It will form an impression, indentation, when you hammer the nail into polycarbonate. So polycarbonate is tough, and whenever you want toughness, so for example this police shields, okay, so even if someone is throwing stones or hitting with a stick, you don't want the shield to break. Okay, means these dugouts for players. So here also, if the players or someone is going to get very rough and fall on these, jump on these, then also you don't want them to break. Now the automobile like front lights covers, okay, front light covers are made using polycarbonate, whereas rear ones can be made using acrylic. Why do you think there is a difference between this front and rear lights?
Because sir, a car is more tendency to hit someone from the front.
Not
Than
really for hitting thing. Okay, that is a possibility too. But anything else? Anyone would like to say?
So because when the car's moving, like small objects might come and hit it at the front
Very
side.
good.
It will.
So basically, when you are on a highway or you are next to a train track, you have to be extremely careful, because these small stones which are there on the road, they can be picked up by the tire and they can be thrown in the reverse direction. Okay, so there are these small projectiles which are constantly sort of flying around, and the front lights can get hit by them. So whatever covering you use for the glasses, they must be capable of providing protection against this flying objects. So the front light covers are made using polycarbonate, whereas the rear ones can be made using acrylic. Okay, so polycarbonate is a very tough thermoplastic. Now, there are a lot of other plastics which are used for day-to-day items. Okay, so you have PET, polyethylene terephthalate, mainly used for these food related items. You have polystyrene, which is a hard but a brittle material. Even though this
Hello?
is, yeah,
Hello? अरे भाई
yeah,
ये तो
yes, who is this? Yeah. All right. So polystyrene is hard and brittle. Now, this is actually not very safe for health, and you should never store anything in polystyrene for a long period of time before eating. So this is also a thermoplastic. Amongst the polymers which are very cheap and used extensively is polypropylene and polyethylene. Okay, so this translucent plastic which you get, these dibbas which you get for storing food and stuff, so this is polypropylene, and it is also used for a bunch of other applications, dustbins and chairs as shown over here. Amongst the hard plastics, you have thermoplastics. You have ABS, standing means, which is an abbreviation for acronitrile butadiene styrene. You don't need to know the whole full form, but just remember that ABS is used whenever you want plastic parts which are hard and tough, okay, but you cannot expose them to sunlight. They tend to degrade with exposure to sunlight. So like protect safety helmets, telephone boxes, automobile bodies, these are all made using ABS. As I told you, two of the most popular thermoplastics, ones which give you some flexibility and also are cheap, are polypropylene and polyethylene. Now, polyethylene, depending on the length of the molecule, okay, so you have something called low density polyethylene, which is compliant and tough. So all these kind of bottles where you can squeeze the bottle and a liquid comes out. So this is polyethylene. This is low density polyethylene. Okay. Also many which one? These consumer items like shampoo bottles, cleaning liquids, powder bottles, oil bottles. So all of these are made using polyethylene, and also the high density polyethylene is used for storing oils and also for dustbins. So amongst the thermoplastics, you want something which is soft and compliant, you go with either polyethylene or polypropylene. You want something which is hard, tough, and can be exposed to sunlight, you go with high density polyethylene. You want something which is very hard, then you go with this ABS material. And you want something which is very tough and transparent, you go with polycarbonate. I know these are a lot of names, but fine. So these are some of the plastics which you use. Now, until now, whatever I have talked about, these are mainly consumer items. Now, coming to engineering components and components which will experience good amount of load, wherever you want good lubrication property, and so something like, let's say, material for bushing, you go with Teflon. Okay, so Teflon is a material which provides low friction coefficient, so it is used as a bushing material. Okay, means basically it's a cylindrical sleeve in which you can have a shaft which is rotating. So bushing is fixed, shaft is rotating. Okay, then you have nylon. Nylon is used for making bearings, pulleys. You have seen the nylon worm wheel in the blender disassembly video which I have shown. Okay, so Teflon is used when friction requirement means when you want low friction coefficient. Nylon is used whenever you want high strength. Okay, and the big advantage of thermoplastics over thermosets, so all of these materials whichever I have talked about are thermoplastics. Okay, acrylic, polycarbonate, polyethylene, polypropylene, nylon. These are all thermoplastics, and which means that they can be recycled. Now when you are recycling, you have to sort of put it into the correct recycling bin. So for to ensure that people can identify the polymer correctly, behind the bottle, whenever you make a plastic component, you put this triangle, okay, these three arrows symbolizing that it is a recyclable material, and you also put a number inside this triangle, okay. So based on this number, you can figure out what kind of a polymer it is, which is what kind of a thermoplastic material you are using, okay. So this is about the plastic materials which are used. Now coming to the cost of these plastics, many of them, so if you look at the cost per kg, first thing is that what do you think will be the density of these polymers? What is the source of means removing that vulcanized rubber, natural rubber, what is the source of all these polymers? What is the raw material which you use? Basic raw material.
Petrol.
So it is a petroleum product. Okay, all these plastics are petroleum products. So what would be their density roughly? Most of them have a density which is very close to 1. Okay, so you can see that this rupees per kg, rupees per liter, there is not much of a difference for most of these plastics. So you can see that the cost of the plastic material is quite low. So if you look at per kg basis, the commonly used plastics, their cost varies. Their cost is somewhere about $1 to $1.50. So most of them, the bulk material cost is less than 100 rupees per kg, okay, and because their density is close to 1, so components made out of these plastics are very lightweight, and when you look at volumetric cost, their cost is also low. So the reason why plastics are being so used so extensively in engineering products is because they are lightweight, they are cheap to means raw material is cheap, production is also cheap, so and you can make them very attractive, you can add colors and make them very colorful. So for all these reasons they are used quite extensively. But that said, means many a times you can use them in non-structural applications. So if the load or the stresses that the material has to handle is very high, or if the temperatures and other conditions are not very conducive, then you cannot use plastics. Okay, so until now I have talked about different kinds of polymers which are used in engineering applications. Now let us look at metals. So I said that you have three classifications: polymers, metals, and ceramics. Okay, now just take a look around you. So in terms of metals, which is the most widely used metal? You must be having a whole bunch of metal components around you, na? What is the most
Iron.
widely? So steels basically
Aluminium.
Stainless steel.
alloys of iron. Okay, so steel happens to be the most widely used metal. Okay, so what are the reasons why steel is so most widely used? One, its cost. So steel is cheap, costing somewhere around 35 to 40 rupees per kilo in bulk. It is very stiff. So what material property should you look at when you are interested in stiffness? What is stiffness? when you say that I have a stiff material, I have a stiff component, what are you referring to?
Deformation.
Sorry? What is the opposite of stiff?
Elastic.
Compliant. Okay, so stiffness, compliance, stiff, compliant. So when you say a material is compliant, what do you mean? What do you visualize? What is the picture which comes to your mind?
It can bend and stretch. It can deform.
It can deform easily. So when a material is compliant, if you apply a force on the material, it deforms easily. So on the same line, what do you understand by a stiff material?
Which cannot
It
deform.
doesn't deform easily.
It doesn't deform easily. Okay, it can withstand loads without deforming. Okay, so if you take, for example, a let us say building. Okay, do you want the building to be stiff or do you want it to be compliant?
Stiff, sir.
Stiff.
You want it to be stiff. You take a tire. Okay, tire. Do you want it to be stiff or compliant?
Compliant.
Some amount of compliance. You want the load to be spread out. You take a bearing. Okay. Now in a bearing, do you want the rolling elements and the raceways to be stiff or compliant?
Stiff.
Stiff, sir.
Okay, so depending on the application, you may either want your material to be stiff or you may want it to be compliant. So stiffness, as I said, refers to the ability to withstand loads without deforming. So what is the material property we should be looking at when we are interested in stiffness?
Elasticity.
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 No, Baba. Elasticity is a,
Young's modulus.
you should be looking at the modulus or the Young's modulus of the material. So what does Young's modulus give you? For small strains, it gives you the ratio of applied stress divided by the strain that the material undergoes. So if this elastic modulus is very high, what does it mean? For an applied stress, the strain is
Very low.
the strain is low. So whenever you are interested in means whenever you want to analyze the stiffness of a material, you should be looking at the elastic modulus of the material. Okay, so steel has steel has a high elastic modulus. It has an elastic modulus of 200 GPa. Young's modulus of steel is 200 GPa. Okay, now you have a wide variety of steels. Their elastic property is more or less the same. All of them would have Young's modulus of around 200 GPa plus minus 5%. But their yield strength and ultimate tensile strength can vary widely. Okay, so if you take low carbon steel, so can you give me some examples or applications of low carbon steel? What is the most where is steel used most widely? The steel which is produced by the steel mills, where does most of it go?
Construction.
Most of it goes into construction industry. Okay, so as reinforcements in concrete and the frames for different structures. So steel goes mainly into the construction industry. The steel which is used in construction industry, what variety of steel is it?
Mild steel.
High carbon.
No,
Low
it is
carbon steel.
or the so-called mild steel. Okay, so what we call as mild steel is the low carbon steel, and that is the most widely used steel. If you go to the market and if you say that dada ek inchi ka rebar dijiye 2 meter ka lambai ka, you say something like that, you are not really specifying the grade of the steel, you are not giving him any other details. So by default, when you say give me a steel bar, by default what you are getting is a low carbon steel rebar. Okay, so low carbon steel is most widely used, and it has a yield strength of around 200 megapascals and ultimate tensile strength of around 300 megapascals. And then if you go to the high strength variety of steels, okay, can you name one machine element where very high hardness steel is used?
Lathe machine, sir.
Lathe machines, yeah.
No, lathe machine is a machine. I'm talking about machine
Cutting tool,
element.
sir.
The
So
tools,
The cutting tool.
gears,
Cutting
pulleys, bolts, bearings, uh, cams, shafts, these are all machine elements. So amongst the machine elements which I have just listed, which one do you think would use steel with highest hardness?
Bearings.
Bolts.
Bearing. Okay, bearings, bearing elements, the rollers and the raceways used in bearings, they use one of the highest hardnesses in the steel components. Okay, so the UTS varies from about 300 MPa to even more than 2000 MPa. So there is a high variation in the strength of the steel, but there is a relatively low variation in the Young's modulus of the steel amongst the different steels which you use. Now, what are some of the other properties of interest? What are some of the other properties of interest? So very quickly, actually I have listed out what are normally of interest. So you are typically interested in cost, its density, Young's modulus, yield and ultimate tensile strength, thermal conductivity, electrical conductivity, and melting point. Okay, in some applications where you are interested in corrosion, electrochemical potential is also of interest. Now, steel has a relatively low thermal conductivity. Low carbon steel has about 45 to 50 watt per meter Kelvin. And which variety of steel has low thermal conductivity? Which variety of steel has low thermal conductivity?
High carbon steel.
No, stainless steel. Okay, so carbon steels, all of them have about 45 watt per meter Kelvin. Stainless steel has a thermal conductivity of about 15 watt per meter Kelvin. That is the reason that if you take a stainless steel vessel, put it on gas stove and then leave it alone for a while and then pour milk or anything else in it, there are some very strong thermal gradients. Some places become very hot. So that's a bit of an issue. So in cooking, low thermal conductivity is bad. Now, so in terms of usage of steel in India, the annual usage is around 60 million tons. The reason I mentioned annual usage is just to show you how widely steel is used. Next to steel, the most widely used metal is aluminium. Okay, this is the next most widely used steel. And look at the usage. So steel, the usage is 60 million tons, and aluminium, the usage is 1 million tons per year. So steel usage is 60 times more as compared to aluminium, which is the next most widely used metal. Now, aluminium is costlier, lightweight, it has low stiffness as compared to steel. Again, as compared to steel, it has lower strength. But its main positive features are its density is low, it has high thermal conductivity, it has low electrical resistivity and low melting point. Okay, what is the advantage of low melting point? What
the
is the
recast.
Easily casted.
you can, because of this low melting point, you can do something like die casting. Okay, for aluminium you can use steel molds to cast aluminium. That really helps in terms of mold making. And yeah, you can do pressure die casting of aluminium because it has a low melting point, so casting is easy. easier with aluminium. So can you name some applications where this high thermal conductivity is used?
Transmission lines, electrical transmission lines.
In
Wiring.
electrical transmission lines, you exploit the low electrical resistivity values. Where do you exploit this high thermal conductivity?
Heat sinks or
Utensils.
Utensils.
In
Okay.
heat
exchangers.
Radiators.
for utensils, and then also for engines, for making engines. So wherever you want to create small thermal gradients and you want to spread out the heat uniformly, there you can go ahead and use aluminium. Okay. After steel and aluminium, the next most widely used metal is copper. You can see the usage. Okay. So copper is also usage. Actually, copper, aluminium, zinc, their usage is all on similar lines. Now, copper is a soft metal. Okay, very rarely you use copper for structural applications. It's very expensive. It is dense and expensive. Okay, so for the same volume, it will be heavier, even heavier than steel, and it is more than 10 times the cost of steel. So it's very expensive, and its biggest positive feature is its high thermal conductivity and high electrical conductivity. Okay, so it is mainly used for power cables and also in heat exchanger applications. Then you have a bunch of other metals which have specialized applications. So zinc, where is zinc used? Zinc has a low melting point. Okay, none of the properties are of great importance except for this electrochemical potential. Okay, so it has even more negative electrochemical potential as compared to iron. So what is the means where is zinc used?
In batteries.
Galvanization.
Galvanization. So you can see these bolts, they are all appearing whitish in color. That is because of the molten zinc coating on top of the bolts. You must have seen all these railway bridges, okay, appearing whitish. The guide rails, not guide rails, the protective railings on the roads, particularly on mountainous roads and all that, that they also appear whitish in color. That is, all of them basically have this zinc coating on them, galvanized. They have been galvanized, okay, to protect the steel components from rust. So tin is again another material with low melting point. Tin initially used to be used for making this tin cans. Therefore, we refer to these cans as tins. Okay. Now there are a few fancy materials like titanium and nickel based alloys. Titanium, as you can see, is a very expensive metal, but means it has low density. It can be made to have high strength, and also it has excellent corrosion resistance properties. So and is biocompatible. So corrosion resistance gives it this biocompatibility. So you can use them for making implants, and they are also used for making this aerospace components. Okay, so in some applications like space applications, aerospace applications, biomedical implants, you don't think about the material cost. There are several other costs involved. So over there you use titanium, and the most widely used titanium alloy is this Ti6Al4V. Okay, this alloy composition is most widely used for titanium. For nickel, nickel is used for making this high temperature resistant alloys. They are called super alloys. Nickel based alloys, they are called super alloys, and they have very high, means excellent high temperature strength. So they are used for making all these jet engine components, and then exhausts of some of the vehicles and all that. Next, you have tungsten. So tungsten has very high density. Okay, it's a refractory metal, meaning it has very high melting point, 3400 degrees Celsius, and it is used for making inserts in machining, and it is also used in weaponry. Okay, so inside bullets, armor piercing bullets and all that, you use tungsten because it has very high melting point. It doesn't soften upon impact. Well, you have lead also. So I have a few specific alloys. I'll just cover them quickly and I'll go in detail in the next class. Okay, so I have listed out a few specific alloys which are used very widely. So for steels, for making shafts, cams, you use this 4000 series alloy, specifically 4140 and 4340. These are used for making gears, cams and all that. For bearings, bearing elements, raceways, rollers, you use this AISI 52100. I'll cover them in the next class, the details. In stainless steel, you use for cooking, you use this SS304 variety. And wherever very high corrosion resistance is required, let's say in surgical appliances, food processing, medical processing industries, you use SS316 alloys. You have ceramic parts. Ceramics are normally raw material is in the form of powder and you use sintering in order to get the ceramic components. So you have alumina, silicon carbide, tungsten carbide, yttria. So these few things where I'm just rushing through, I will be covering them in the next class. Okay. So now, just like all other classes, I'm going to share with you. Just give me a second. All right, so I'm pasting this form in the chat. Just fill it up. I'm stopping the sharing. I'm
Sir,
here.
it is not accepting responses.
Just try it. Why is it not accepting? One
So
second.
you put the time as 11 and it is 10.
Oh, okay. One second. It will accept now. If you get into machine design, so my own personal favorites are amongst the
Sir, your voice
polymer.
break. Can you repeat?
Yeah. So I said that once you get into machine design, as you start designing things, you will develop some favorites amongst the materials. You have many materials, but there are some which you tend to use again and again. So my personal favorites among the polymers are silicone, nitrile rubber, uh, polycarbonate, ABS, nylon, and amongst the metals, of course, steel,